Hey, what's going on, guys? Let's do this problem right here. Let's see whether this one is converges or diverges. So to do this problem, first we get this one right here, 1 over n cube, like whatever the power we have on the bottom, right? So 1 over n cube, and check whether we can compare directly, right? First, that's the first thing. And if we look at this, we know this n3 minus 4 is smaller than n cube because we are deducting 4 from here, so n cube. Therefore, if I divide, like let's say 1 over n cube minus 4, and if I divide this one by this is like 1 over n cube, right? 1 over n cube, and this is bigger than this. If I divide like a number by a smaller number, that's going to be bigger. So this is going to be bigger than this one. Compare. Like, we have to just compare. So this, since in this case this is the case, if we have a convergent right here, let's say this is a finite number, we are not sure whether this will be a finite number because we have this one from 1 to infinity, right? If it's bigger, it can be any number, it can be infinity too. So we can't really do the direct comparison in this case, right? So in this case, what we do, we try to take the limit. So limit, what we have to do, we take this one as an, let's say this is bn. So I use different color right now. Okay, so let's choose this one. So a and bn. So what we do, we just take the limit n approaches infinity and divide an by bn. So if I do that, this is going to be 2 over n cube minus 4 divided by 1 over n cube. Now I can flip this around and multiply. So this is going to be equal to 2 over n cube minus 4 times n cube over 1, and we will end up with, so I have to put the limit always, so this is going to be limit n approaches infinity, right? Infinity, let's continue right here, limit n approaches infinity, and then we have 2 n cube over n cube minus 4, and now what we can do, we just divide everything by the highest power. So in this case, n cube, this one will go away, but this will be 4 over n cube. And if I apply infinity, this will become 0, and this will get just 2 over 1, right? So 2 over 1 minus 0, that's going to be just 2. Also, if you want to do it in short method, you know, since we have the same power in the top and the bottom, whatever the ratio we get, that's going to be the value. So that's another method to do that. So we have this 2 right here, and since this is a positive finite number, a rule says that if we get a positive finite number, this both of this will give the same, but like if this is convergent, this is going to be convergent. If this is divergent, like if you take one of them, it will be true for both of them. So that's what it says. So we know this an, bn, this is an, this is bn. So if I take bn alone, 1 over n cube, we know that if the power, we have a general rule right here, like if the power of the n, like if the power, let's say np, if the p is greater than 1, it's convergent. So if the p is greater than 1, it converges. If the like it's 1 over np, if the p is less than or equal to 1, that diverges. So this is convergent. That's a general rule. Therefore this one, we know this is convergent. Since one of this is convergent, we know other one also convergent according to this one, since we have the positive finite number as a limit. So we can conclude, therefore we can conclude that sigma infinity n minus 1 2 over n cube minus 4 is convergent. And that's how we do that. I hope you guys like this video. See you next time.